Hey everybody, this is Larry. This is day 28 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, which apparently I've done. 352, data stream as disjoint intervals. Okay, let's take a look. Okay, so given a data stream of non-negative integers, a to a sub n, summarize the numbers seen so far as a list of disjoint intervals. Okay, what does that mean? So we add 1 and then we add 3, okay, and then basically you have get intervals and get nums, okay. I'm trying to think whether you know how intense it should be. And here I'm looking at the value, so, and the number of cores. In theory, you can imagine 10 to the 4th cores to add num and then get intervals. I'm just trying to think whether we can do a get interval in where, you know, you put in a set and then you just loop through it, but I think that may be a little bit whatchamacallit, that may be time limited, right? Is what I'm trying to say. Sorry, couldn't find the words right now. My mind's a little bit blank. Yeah, just so that it'll time limited if you're not careful, because it's just 10 to the 4th square, which is 10 to the 8th. Okay, so then the second thing, the two things that I'm trying to think in my head is either using a sort list or a union find type thing. The idea behind the union find is just that basically, well, two things, right? One is that using a sorted list, at least in Python, somewhat approximates using like a binary search tree or something like this, and then you can kind of get a range in that way. You can imagine that if we, you know, maybe even using a segment tree type thing where, you know, you have a shortcut where for each node on that segment tree, if you have an entire thing, you can kind of early terminate, and in that piece you can maybe kind of figure out in log n pieces at most to sum it up or something like that, right? And then the other thing that you can do is using sorted lists, and then just kind of do a lot of bookkeeping that way. You do a binary search to see where you would insert, and then you just kind of look at the left and look at the right. And then the union find implementation is just also, well, you insert a number, let's see if it and are these numbers guaranteed to be in there, or I guess technically not, right? Or like, can you add the same numbers? What I'm trying to see, but it doesn't really say, so that means that I can assume it doesn't, or it is. But yeah, you can imagine a union find is just give it a number, you union it to the left and you union it to the right. So that's basically the idea. I think I'm going to do the union find this time, because I don't think I'm confident about the union find. I don't know if it was this problem or something similar where there's something similar to this, and I think that time I did not use union find because I wasn't confident about it, but now we have more, you know, I could explore it a little bit is what I'm going to say. So okay, so basically what are we doing, right? So basically we have, you can yeah, so I'm thinking through it a little bit before I kind of speak, even though I guess sometimes I talk about it loud, but I'm just thinking through how would the states work, because with the union find, you have to keep track of whether, you know, you can't just union left and the right, you have to make sure that they exist first. And I'm just trying to think in my head whether it is sufficient that we just keep a variable on it. And then maybe that's good, but I'm just kind of working through that in my head. So let's just say we have something like this. Oh, they don't tell you the max value. I mean, I know that there's this constraint, but I think in theory, I don't like kind of abusing this, but whatever, I guess. I guess it is fine. Let's just add a small number to it, right? And then maybe max is equal to I for I in range of max. Yeah, something like that. And then now we have the union find portion, which is just the parents. Is it, what do they call in union find? I guess parents, right? Or parent, whatever. Also I for I in range of max. And then now when we have a number, we go, okay, right? So let's just say we add value, then there is one more thing I have to keep track of for the get intervals so that we can speed up. But I'll get there when I get there. That's what kind of triggered in my mind. That's why I kind of paused a bit. But this one's, I mean, at its core, it's just a lot of bookkeeping. So it's not, it's just thinking through about whether the bookkeeping is sufficient for me anyway. And that's basically what my internal dialogue looks like or sounds like. Okay, so basically we add a number. So, okay, so self.added of value is equal to true, right? If self.added value minus 1, if this is true, then we kind of just union the two together. So maybe self.union value minus 1, right? AB, and then we have self dot find x, right? So if self dot parent of x is equal to x, or if this is not equal to case, then self dot parents of x is equal to find self dot parent of x, and something like this, right? And then the union will basically so UA is equal to self dot, I forgot to put in self. Find of A, UB is equal to self dot find of B, and then basically self dot parent of UA is equal to UB, kind of. No. We want the parent to be the I guess there's really no way to kind of keep checking that. No, I guess we can, right? So, yeah. If UA is for whatever reason, then we swap. We want to make sure that this is a small number, and then we have to update the max of UA is equal to basically what I'm trying to do, and this is the part that may be a little bit tricky, is that when we add two numbers, we want to make sure that the max is updated, right? So basically self.max of UB, because basically the way that I'm writing this is not so I would say one thing is that, just to be clear, is that I'm not writing a generic union find thing. I'm writing it in a way such that it works for intervals, right? Meaning that you have a continuous line or whatever, or in this case, discrete line, sorry. And then when you only merge two things next to each other, so then there are some additional properties. And I want to say that because of that, this would never happen. Or, well, I mean, I guess it can be, because A can be bigger than B depending on how we write it. But once we swap and UA is less than UB, you can think about it as there's a left chunk and a right chunk, right? So there's no like weird overlap in which some, like if you think about a union find as a tree, there's no thing where some subpart of that tree is going to be on the right, to the right side, right? It is just a left component and a right component, and because of that, and when we merge them, it allows us to kind of do stuff like this. I believe so. And UA is the smaller number, so then yeah. And then here we set it to the max of UB because this is kind of like that the right most. I don't know if this is quite correct, to be honest. So I will have to kind of see if this is good. So yeah. But this is my theory so far, or at least I think this is true. And then yeah, and then that's pretty much it for this part. But then here in theory, I'm gonna write the naive wave, but that's still gonna be too slow, which is that I is equal to 0, well I is less than max, right? Then if self dot added of I, then we get the self dot max, right? Let's just do answer thing. Then answer dot append, we start with I, and then we go to self dot max of I, and then I is equal to self dot max of I, and then we increment, and that should be good, maybe, or at least it's, we'll see. Oh, name find is not self dot find. So this is okay, but I suspect that this will be too slow because this is a for loop. But and there is an optimization to be done here, but I'm going to YOLO it just because I'm curious whether this is good enough. It may time out. Actually, probably will time out, to be honest. Yeah, I mean, it took 5.4 seconds, but it didn't time out. So let's try again. Why did I do it in November? Was this just like a random bonus question? Was that the bonus question I did that time? Okay. So then now we're trying to optimize this part, right? For this part, basically we have this I and a max, so then we have to get all the beginnings of it, right? So that means that we're trying to find the root of all the stuff that's in here. So maybe I have something like, basically we're trying to get the beginning of the intervals, right? So maybe I have something like, let's just say it's going to be a set. Maybe seen isn't quite the right word. But then when we have a union, what do we do? Well, we can say that UB is no longer a thing. So then here, self.scene.remove UB, right? In here, we do self.scene.add value. And then here we remove UB, only retaining UAs. And then here now, then all we have to do is get it from a list of thing, which of course you can actually use a sorted list. The only reason why I didn't use a sorted list because I said I wouldn't. I don't know. I don't know how I feel about it. But so yeah, so you have self.scene, let's just say sorted, right? So same thing basically, and then that's it, maybe. Let's see if this should be faster. Oh, I made it. I did think about whether this could be the case, but I guess here no. If this is not in there, I wasn't sure whether this would be true. That I couldn't prove it in the. I didn't think about it too deeply, to be honest. But I was thinking about it. But how can it be removed twice? I guess that's the question. Oh wait, this is a different. Oh, because you could add the same number twice. Okay, I guess maybe that's why. Okay. Okay. Well, I guess that was my earlier question that we had, but how come there's no like copy this thing over thing? Okay, fine. Do it the hard way. I think if the numbers were unique, I think that would never get hit. But maybe I'm still wrong because there's some like weirdness here. What am I doing? I'm returning 7 7, but so so there is a wrong thing anyway. So I guess I'm happy that I didn't. No, I wouldn't say happy, but maybe that's also related to this thing still. It may be that this part is wrong too, because I kind of assumed that the same number won't be added, but maybe that's a bad assumption. I don't know, because basically 6 6 and then it adds a 7. It adds a 7 6. So here it adds 7 6 7 6 6. UB should be 6, UA should be 7. We swap, and then we remove the 7. So this should be 6 and 7 right afterwards, after adding the 7. And then we do 7 8. 7, this is going to be returned 6, and this is going to be returned 8. It still should be good, but well, I mean, here it's good. It's 6 8, right? So it has the 6 8 already. And then what did we do? And then for some reason we lost the 6 8. Probably this operation. So we add the 7, we good, and then we add the 6, and then we lose the 6 8. Why? When we added the 6, and then 5 is no good, and then 7 again, but 6. Oh, because this is the same value. I see. Well, at least that solves something. But then now we added 7 because we added 7 again. And all of this is actually, even this one is because we're adding the same number twice. So maybe I could just check for that. That's the part that I was debating doing. Maybe scene would have been a better word for it, but dupe maybe. Then, you know, something like that. Okay, yeah, because all my, the thing that's sometimes the tricky part about it's a little bit faster, but still slow. What did I do last time? I guess sorted list. Oh no, stack. Oh no, I did a sorted list. Well, I did a sorted list and then I merged them, so I don't know if that counts. But so I think one thing that this demonstrates is also that when you make changes, sometimes the preconditions of the things that you assume to be true just may not be true. So you have to evaluate all the preconditions and just to hold them constant. For example, for this case, I just assumed that there wouldn't be dupes, and therefore when I added stuff like this, well, it just wasn't true. And then because in my mind there's a state diagram, right, of like a finite state automata type thing, but however, because of this dupe thing, it kind of messed with those states, and well, there are two ways to think about it, right? One is either to kind of redraw your finite state automata, your state diagram, which I tried to do a little bit, which is why, we ran into other issues. Or the other thing is just, well, if you knew your issues with dupes, then just get rid of the dupes, which is kind of what we kind of did. What is the complexity, right? This, with path compression, let's just say this is O of 1, then this is going to be O of 1. This is also O of 1-ish, depending on how you count all the set additions. This is kind of n log n, but maybe you could have used a binary search tree type thing to kind of keep scene in its way. I mean, then it'll make this log n, but this would be done in then just linear time instead. So maybe it's worth it. Depends on what you're doing, I suppose. But otherwise, this is n log n for that reason. You can also use a sorted list, but same situation, right? this will be login instead of all one. But yeah, and then just go through it. Cool. That's all I have for this one. That's all I have for today. Let me know what you think. Happy Friday. Stay good. Stay healthy. To good mental health. I'll see you later. Take care. Bye bye.